Good afternoon. Excuse me. Today we are going through notes 4.2, multiplying and dividing rational expressions. The rules for multiplying rational expressions are the same as the rules for multiplying fractions. You multiply the numerators and you multiply the denominators. So when you had like a fraction like 1/2 times 1/3, right? 1 times 1 is 1, 2 times 3 is 6. So same concept. So there's the rule we're going to use, right? Here's the example, right? As long as they're non-zero, right? This works. So multiplying, right? So we're going to multiply 6r, 3r squared. So that's 18r to the fourth. 5 times 7 would be 35s to the fourth. Right? Remember when you're adding, when you're multiplying or variables, you add the exponents. So that's why it's r to the fourth and s to the fourth. So that would be your simplified answer because there's no common factors to reduce like what we were doing in lesson 4.1. Okay, example 2. Right? Before you multiply, I do notice that there's a GCF here. So I could factor out a 3, so you get c minus 1. So I could reduce the c minus 1s. And now if I multiply, I have 4 on top. And then 2 times 3, so 6, which gives me 2/3. So this time I, simplified, right, by factoring first and then multiplying. So there are two methods to simplifying rational expressions. You can first multiply, you can simplify and then multiply, or you can multiply then simplify. That's usually my preferred method, is to try to simplify as much as I can and then multiply. So example 3, right, I'm going to put this over 1. I'm going to factor everything, see if there's any common factors that I can reduce. So the trinomial, right, it's got to be two binomials. So x times x, 1, so x plus 1, x plus 1. The denominator is a difference of squares, so x plus 1, x minus 1. The other trinomial, we have x times x. 3 is prime, so it's 3 and 1. It's got to be a plus 2, so minus 1. And then this is over 1. So now I can simplify. So the x minus 1, the x minus 1 reduce. That x plus 1 and 1 on the numerator reduce. Doesn't matter which one. So now I've simplified, made it a little easier to multiply. So multiply straight across. You have x plus 1 times x plus 3. You can put it over 1, but you do not have to. So that would be your simplified answer. So by factoring, I was able to reduce and make the work a little easier before I multiplied. Example 4. Same idea. We can reduce first. So I do see a GCF. So if you factor out a negative 4, this would be c minus 4. So the c minus 4s will reduce. So there and there. 5 goes into 5 once, into 45 9 times. So now when I multiply, in the numerator I have just 9, right? Because all there's left is a 1 times 9. In the denominator, I just have 1 times negative 4. So I get 9 over negative 4. So I was able to, again, factor, simplify, and then multiply. Once I made the work a little easier by simplifying. Now, when we're dividing rational expressions, we want to remember the phrase KFC. So keep the first fraction, flip the second fraction, change the sign to multiplication. So realistically, you're never going to do division. So think back to the days when you had like 1/2, right, divided by 1/3. How would you do that? Right? You would keep the first fraction, take the reciprocal, change the sign to multiplication. Right? So that's what we're doing here. Just a little bit more complex because we're working with polynomials. So first fraction, I'm going to keep, right? KFC, keep. So x plus 4, I'm going to factor the denominator. So 3 times x plus 4, because I see the GCF. Take the reciprocal, flip the second fraction. Change the sign to multiplication. So now, again, just like I did the first few problems, Are there common factors that I can reduce? The x plus 4, so there's a 1 left. The 3 goes into there once, into there twice. So now if I multiply, 1 times 2x squared is 2x squared. 1 times 1 is 1. Or we don't have to write it like that. We can just leave it as 2x squared. So we took the reciprocal, we factored, reduced, and then multiplied. So again, you're going to see me when I do these problems, usually I factor as much as I can, see if I can reduce common factors, then multiply. Okay, example 6. Okay, see a lot of things that I can factor, so I'm going to factor the first fraction, because I'm thinking keeping the first. So 2 trinomials, numerator, denominator. So factors of 8, that gives you 6. That's plus 4 plus 2. Factors of 2, that give you 1. So 2 and 1. So plus 2 minus 1. Okay, now the second fraction I'm going to flip. So the x plus 4 is now here. The 2x plus 4 I'm going to factor by taking out a GCF of 2. And then I'm going to change the sign of multiplication, which I got ahead of myself and already did. So now, do I have common factors? Well, the x plus 4s, the x plus 2, the x plus 2. So multiply 2 times x plus 2 over negative 1. Again, you can write it there if you want, but you do not. Oh, why did I say negative 1? Whoops. I forgot to write my x minus 1. So over x minus 1. And again, if you're wondering why did I cross out the 2x plus 2's on the left, it doesn't matter which one you reduced with. You could have reduced all the way across if you wanted to. The numerator in the far right all the way to the denominator in the far left. That would have been fine. You just can't cross out x plus 2 in the numerator and x plus 2 in the numerator. You can reduce vertically and you can reduce diagonally. You can't reduce top to top or bottom to bottom. Okay, example 7. Right, so we can keep the first fraction. That's a difference of squares though, 1 minus n and 1 plus n. Take the reciprocal, so this is n minus 1. And I can factor out an n from here. So you have n minus 4. And change the sign of multiplication. Keep, flip, change. Okay, so now I do see that I can reduce the n's. Okay, now n minus 1 and 1 minus n are very similar to each other. So if instead of taking a positive 1, if I factor out a negative, that would flip those, change their signs. So now this becomes n minus 1. Oh, look at that. Now they're the same. So you have negative 1 plus n times n minus 4 all over 1. So I can just leave it like this. So again, I factor out a negative because I saw 1 minus n and n minus 1 are very similar to each other. They're just opposites in signs. And anytime you factor out a negative 1, the only thing you're doing is changing the signs of what's in the grouping symbols. Okay, example 8. This looks a little interesting. This is different than the last few examples, but it's still a division problem. So I'm going to keep the first fraction. Flip the second one, so take the reciprocal, so this would be 2x plus 8 over 2x squared, and change the sign to multiplication. So now it looks like the other problems. So I do see that there's a GCF in the numerator of the second fraction. So that gives me an x plus 4 when you factor out a 2. And now I see some common factors. So the x plus 4's reduce. The 2 reduces with that 2. So in the numerator you have a 1, and the denominator you have an x squared. So there's your simplified answer. So really there shouldn't be any division. It's always going to turn into multiplication. And then we're going to just skip number 9 so you don't have to worry about that. So all you need to do is answer your essential question at the top of the page with a 3 to 5 sentence summary. So go back to the top of the notes, read the essential question, and come back down here and write a 3 to 5 sentence summary answering that question. Once you've done that, you are done with your notes for 4.2. Have a great day.